Using backend languages for frontend, why ClojureScript is an awesome idea, and also when it's not an idea. I'm Tobias. I'm, as you have seen, Senior Product Manager at Metro Digital. And if you ask yourself, okay, are now product managers also doing developing? Yes, in my past, I was a full stack engineer for more than 5 years, and Clojure stick to my heart, and therefore I'm doing also Clojure and ClojureScript in my free time. But when I'm not in my free time, I'm working at Metro Digital. We are the internal product department of the Metro AG. So who of you know all the blue boxes that are not IKEA where you can get a shitload of food? Okay, most of you. Most interesting stuff from Metro Digital is we are located in 6 cities. So here in Germany, then also Romania, nowadays also in Vietnam. We have services from more than 21 countries where Metro is located. More than 900 employees. We are still growing. That's why we also opened the location in Vietnam. Those employees manage more than 1,000 services in the Google Cloud. And most important is we are remote-first companies. Yes, we have those offices, but if you're located here in Hamburg, in Munich, somewhere else, we do not care because we hire from everywhere in Germany, but also respective from Romania and Vietnam. But why Clojure? There are some good reasons why you should do Clojure. First of all, the language itself is rather simple. Everything you have in the language is just data. Even the code is representative of the data itself. It's everything written in a list. Clojure runs on the JVM. Therefore, you have the interoperability between Java code and Clojure code. If you have maybe some high security authentication library inside Java, you can directly use it in Clojure. If you have some huge mapping function in Clojure, you can use that in Java. That's pretty handy. Then Clojure has a functional programming languages with all the advantages, but sometimes also disadvantages. And it's Lisp, therefore Lisp processing. Clojure is made to really work on huge data sets, and you can imagine Metro as a wholesaler, if we have customers for the Oktoberfest or something like that, they have really big orders and have a service in Clojure that is really calculating, doing stuff, managing the order. That's pretty easy. Why on top of Clojure doing ClojureScript? Because it's simple. It's the same language. You do not need to learn different languages for the front and back end. You can just use the same language. Also there you have the interoperability between JavaScript code and JavaScript languages and ClojureScript. It's the same because it's directly compiling to JavaScript. The ecosystem itself, it's quite stable. Who of you is annoyed if you have a new package JSON, you update that, and you can just brew a coffee and wait for 5 minutes because you have so many dependencies? Yeah. Normally you do not have that with ClojureScript. Most libraries are very, I would say, stable. There are, of course, also some projects that haven't been touched for 4 years because there was no need to. The code is just, I would say, true. It just runs. ClojureScript also comes with a tool set of everything you need for debugging, tracing, looking to your stack, what's really going on. Directly everything out of the box, no need to install further things. But when to not use Clojure? If you do not have the time and the nerves to go into functional programming. Who of you has ever done Haskell? Who of you was not a friend of Haskell then? Not so many anymore. But who of you have done Haskell, you know, coming from the object-oriented world and then going to a functional programming language, it hurts. It really hurts to do that on a professional level. Second disadvantage is the community. It's rather small in the world. compared to Java and other big frameworks or languages. Therefore, sometimes it's a disadvantage because you cannot ask so many people on Stack Overflow. Maybe you only need ChatGPT nowadays. But also the community you have is very powerful. So it's partly a disadvantage. The adoption rate in a company can be rather difficult. If you have a product team or some service team managing the services, and you drop off, there has to be at least one more guy who is able to do Clojure. And that's tough in the real life out there, because there are not so many Clojurians that are able to maintain the code. Performance is the last thing. If you have a service that is really into performance, into the last milliseconds of execution, any framework that is compiling from a higher language than to JavaScript is not the best solution. Therefore, also ClojureScript isn't. Let us have a quick look how Clojure looks like for everyone who hasn't seen Clojure yet. Nil is in Clojure somehow not in list, it's the none value. Therefore, all slides are also online. You can play with them also after the talk directly, also should work on the smartphone. In Clojure itself, you have also numbers, you have floating points, you can have characters, that's all the same in basic stuff. What's more interesting, how to write functions and variables in Clojure. Or here, it's directly ClojureScript because it runs in the browser. Everything you do in Clojure is written in a list. Lists are just written in parentheses. And if you want to define a variable, you just write define x and then the value, for example. And below that, you can directly see here ClojureScript, user, and then x. User is the current namespace where we're moving, so the area where this variable is defined. Functions are then not only def, but def-n for function. And let us imagine we want now have parameters inside the function. Parameters are via vector, so those are vectors. And then we can say we want an execution of x and y. Of course, we need x and y also as parameters there. Everything that is inside parentheses will be executed and evaluated. The most inner parentheses first, and then Clojure's working to the outer parts. In the beginning, you always have the operator, like here, the addition, and then you have your parameters. So what that function is doing, taking two values and doing an addition. If you want to call this function, I forgot the name for this function. It's, of course, add. And now you see you have the add function. If you want to call it, it's just saying the name. It's the operator here. And then you want to have x and one more. And that is already all the magic you need, basically, for Clojure. You can also write some print line commands like this one. So print line is executed to, it prints something on the command line or here in the REPL, so read, evaluate, print loop, another tool of Clojure. But the command itself is nil because print line does nothing in terms of execution. Therefore, you see first the printout and then the nil value again. Here is a more interesting comparison between now JavaScript on the left side and ClojureScript on the right side. On the slides, you have also more examples if you go them after the presentation, and you can see also here again, you're defining some of a function that is called distance. You have two different points. Let is creating a scope for temporary variables. Therefore, in here, a is a specific value, the distance between the x values. B is right now a temporary variable for the distance of the epsilon values. And then you're calculating the square root from the JavaScript mask bibliography, and then the good old distance between 2 points. This one is rather ugly. You can also do much nicer code in JavaScript and ClojureScript. But that should only give you a feeling how the code is structured and how dense the code can be. So therefore, the overview of functional programming language is often much higher than of common programming languages. If we now go into the first ClojureScript project, some live coding will come then. What do you need to start directly with ClojureScript? We have a dependency file, we have a shadow file for the browser, and the good old package.json. For the framework that we are using in a few seconds, I will use reframe. And in reframe, we have 5 different steps. So like in every front end, we have events that will be taken and triggered, effects caused by those events, queries to respective taking the app state into the front end, manipulating the views, and then rendering the views, manipulating the DOM. That will be the execution steps we'll see. Here's a dependency, how it's looking like in Clojure. You can see it's the same syntax again. You have here now a set. It's like a dictionary, a map, where you have specific keywords, and therefore you have the columns. And this project, you have the source inside, obviously in source. Dependency for Clojure and ClojureScript, some Maven repositories. And if you want to run the code, you can either watch here to do hot reloading, or you can run the server here with the web shop where the project is located. The shadow CL.js is needed for the browser then, to see where should the browser be. So here on port 8777, target is of course the browser that is defined somewhere else. Where is my compiled code, and where is the asset directory? No magic right now, hopefully for you. Short outlook into reframe and all the different steps we have here on the functional wrapper of reagent. As said, we have 6 different steps. You only have seen 5 because one step is split into 2 parts. First one was dispatching events, event handling, side effects, because every event that is rating maybe a value in the database can trigger a different action. For example, if you put inside your web shop an item into the basket has to be refreshed. That is already in side effect. This side effect has to be displayed somewhere, and therefore you're extracting the state. You will render the UI, and the last thing, you do not have to care. It's done by the framework. But we can also skip those slides to make it more crisp, and I can directly open the project. That would be, I guess, better for you. Is this also visible from the last rows? Just raise a hand if okay, it's fine, perfect. That is now the dependency we have here in the test project that is also available on GitHub. Same syntax again. We have now 2 different paths. Here, the one is source, the other one is test, because of course we do in test-driven development also here. Some libraries, a little bit more than in the example. And I have given you some more things like test cases, creating a standalone jar file, and some helper functions for clean code, looking if everything is covered. It's described in the README then. Shadow CL.js, same case again. We have here, I have to adapt the code size. Oh. Should be now readable again. But same again, we have the port for the server. We know where our different options are, what the browser is, where our compiled code will be, our assets. It's mainly the same. And that is then that will take a while. Or directly presentation mode. This one, but let me just fix that for you. Then we can, that should be more easy for me then. And the core function. That is the main entry point. I can see the main entry point. Let me fix that for you. If you're on stage and searching real quick where to mirror the screen. Then let us be spontaneous. And I got the biggest second monitor of my life. Exit presentation mode again. Still readable? I guess so. That is now the main entry point of the ClojureScript project here. What you can ignore directly is everything below entry point. That is a little bit of boilerplate. The most important parts are only that below here we have a function that is initializing the database. And if we have a web shop, for example, here, in the beginning I have the query to the backend to get all articles. But here you can see what is rendered in the beginning is the body. Every web shop, every website needs a body. And this is a new thing that I haven't mentioned yet. This syntax is called hiccup. It's creating HTML inside Clojure itself. You can imagine that is directly a div tag. And this div tag may have an error panel, may have a warning panel. F is only the namespace here of floating elements that I have created here on the top. This one is then subscribing the container variable. So subscribing every time my container variable is changing. It's a single page application. And therefore inside there I have just a keyword that is either shop, checkout, or detail. Of course, also edge cases are catched. And if one of those keywords is inside this container variable, we jump to the shop, checkout, or detail page. For example, the shop is just those lines of code. That's already everything we need for what you haven't seen yet. That's hidden here. That is the shop I'm talking about. You have all the different HTML cards that are rendered. You have different articles. The images, the text, they are coming from a backend. Somewhere a Docker container is running. And you can then add articles to the basket. And on the right side, you can directly see one of the debugging tools where you can just go through the trace and they can just go back step by step. You can now see on the bottom left that the items that I put there from the bacon are decreasing, or if I go into the trace again to the next steps, they are increasing, decreasing. So it's really state management and tracing inside the browser. That's one of the handiest tools for front-end debugging then. What we can also have is the details view. And then, as I told, we can go to the checkout and also remove stuff. That's mainly everything you need in the beginning to have a web shop. And in the backend then, not backend, but in the front-end code, that was the article. And here we are subscribing all articles that are in the database, and we're just iterating there. If it's empty, we have a loader, but then we are creating div elements. And for each article, you may see some common languages, common attributes from Bootstrap. We're creating just a card with few more things. If I click on the card of the details, we are dispatching an event that is the detail page, and you can here see that is the event name, change page. That is one value, it's detail. And here we have the second value because we need to know which detail should be displayed, and here it's ID article. So from article, we are taking the value of ID. What you can also see, what comes with Clojure directly are rainbow parentheses, because with so many parentheses in the end, you would just lose the overview where you are. How many of you find this code ugly? I can totally understand. How many of you find the parentheses quite nice? You have rainbows. At least something. If we have a look at the events, you have one file where you can register all the different events that could happen. Here you have the database that is cleared in the beginning, and for example, clear warning, display warning, that are only the most crucial things. Below here, also the changed page event in the beginning, where you're writing new values in the database. You have the events that can be subscribed. For example, the basket count in the top right, if you want to increase the basket or decrease how many articles are there. The only thing that we need here is we're taking the articles from the database, the execution of that, so the result will be put as parameter into the next function. That is what this little arrow is doing. So execution of one parenthesis and taking this result to the next one. Because there we are mapping the count function, so we are looking into all articles, how many counts of the articles do I have here? So 2 bacons and 1 asparagus should be 3. And then reduce that list with an addition that we only have the number itself, but not all the different things. And here we have, for example, then the shopping cart you have seen, just a shitload of different div tags that are then in a nice style with the CSS. Also the table, that is then looking more manageable than the other thing. And that's already the disadvantage you have, because you can write pretty ugly code pretty fast. I'm not at all the best Clojure developer, since I have a little boy right now at home, 1.5 years old. There's not so much free time, and in my free time I try to sleep a little bit. And that is also the reason you can see some monster functions like this one. I believe that you can do much better as active developers, but once you get lazy like me as a product manager, you create those monsters. Let me jump back to the presentation. I will skip through that. We have seen all the different things. That was magic, covered by the library. That is also working in the browser here. I do not want to scroll. I want to go to the last slide. Here you have also the repository directly, the first link. You can also play with the slides directly. ClojureScript is embedded. But if you want to talk to me, I'm either here, I'm at our booth that is next to Cinema 8, or tonight also I'm there. I'm also in a panel at 2, or tomorrow on another talk about product strategy, where I'm more active again. Are there any questions where I can help you?